And hello everyone, welcome to the Radical of Math. My name is Dwayne, and to start our channel right, I said we should do some math together. So grab yourself a pen or pencil and a scrap sheet of paper. No calculator, no tablet, cell phone, Desmos, Wolfram, Alpha needed for this, just your brain. Here is the question. X equals 2 cuts the relation x squared plus y squared equals 16 into two sections. What is the area of the smallest section? So I'm going to give you a moment to kind of think about this. Go ahead and pause the video at this time, start working on your solution, and in a few moments, we're going to begin doing the actual mathematics to calculate this answer. So welcome back. So we're given two equations. And we're told that these two equations intersect and you have a larger section and a smaller section. So the first thing to recognize is what x equals 2 really is. So here's where we're going to need to draw a coordinate plane. And x equal 2 only says that every x coordinate, every abscissa will be in the order pair 2, comma, and then whatever the value of y is. So let's go ahead. We're going to put in 2 units here, and then we're going to draw this line. That is x equals 2. Now, the other equation is a little bit more involved. Now notice, I didn't say this was a function because it's not, simply a relation. So, geometry students will recognize that this is a circle with a radius of 4. And if you only had Algebra 1, you can plot some points and figure that it also makes a circle. And so we're going to go out to 1, 2, 3, and we'll conveniently do that 4, then 1, 2, 3, 4 right there, and so on and so forth. And so now we're going to roughly draw a circle. I do not have a fancy tool here, so we'll just say that's for the sake of, and then that, and there we go. Rough circle, you get the idea. So we know from the circle that the radius is 4 units. So what I'm saying is this to there is 4 units. So how do we go about determining the area of the smaller section? Well, let's note that the area of the circle will then have a subtraction because of the semicircle, and then you're going to have a second subtraction, and then there's going to be a third subtraction. So how do we get to that? Well, let's start with the big circle. So we know that the big circle is 16 pi. So use the formula pi r squared. Radius of 4, we know the whole thing is 16 pi. But we immediately have to subtract half. So this half right here goes away because that is the half circle. And so now we know that the area of the right side, so I'm going to say this is the right side, a sub r, is 8 pi. So for the sake of ease, what I'm going to do is I'm going to erase what is in essence the left side of the circle. Because we've already accounted for it here. We know this whole thing is 8 pi. Now, the next challenge is we know that this is what we're trying to calculate. It says smaller section. So that right there tells you that this smaller section is less than 1/4 of the area of the big circle. So if you tried to shortcut the problem, sorry, that's not the right answer. However, if you'll note, you have a couple of right triangles. The radius is still 4. We're just working in a half circle. And so what we realize is we have a couple of special triangles, 30, 60, 90 triangles. We know this is 30, and we know this is 60. And we know this is 2√3. And then rinse and repeat down there. So we know this right here is also 60 degrees. So if you don't know a special triangle, just do the Pythagorean theorem and you'll come up with the same conclusion. The difference is you won't know the angles. So this is an important fact that you need to know to solve this question. And so now what we're going to do is we're going to subtract these two areas right here. So everything's 8 pi. And then we're going to go minus. And since we have two triangles, if you flip this around, you simply have 2 times 2√3. And that are the areas of these two triangles combined. So if you were to rotate this, you have a side and you have right angles. Therefore, we can just use the rectangular formula, area equals x times y. We're going to subtract that out. So we have now addressed this right here. So the only thing that is left is this bit here and this bit here. So the first thing to note is we know what the angle is. It's 30 degrees. But also note it's cutting an arc. And you have an arc down here as well. And so we need to know the area of a sector. And so in this case, the area of a sector is represented as this. So we have 30 degrees. The whole circle is 360 degrees. Note, if you try to do this in radians, this is not the formula for radians. It is theta over 2 because there are 2 pi radians. So keep that in mind. So the fraction of the 360 degrees you're taking out multiplied by the area, and since you have 2 of them, you have, in essence, a doubling effect. That is the area of this shaded region. So let's compute this. So we have 8 pi minus 4 square root 3 minus 1/6 pi times 16. So I've multiplied this number. I've gone ahead and put the 2 in already here. So I have 60 over 360 degrees. That equals 1/6 pi. And we know what r squared is because that came from the original equation. Let's continue to simplify. So we're going to have 8 pi minus, and we're going to deal with this term here first. So 16/3 is 8, or pardon me, 16/6 is 8 over 3. We're just divide everything by 2. Minus 4 root 3. So now these two values will simplify. So we know 8 pi is the equivalent of 24 over 3 times pi. And so our final answer is 16 over 3 pi minus 4 square root 3. That is our final answer to the area of this shaded region. So I hope you join along as we not only do math together, but we also troubleshoot many of the flaws in mathematics in the United States, especially at the high school and lower undergraduate level. Take care of yourselves. Take care of one another. God bless. We'll see you next time.